was there. Did you know I was there?
I don't think you ever said anything, so
No,
I
you
probably
said
knew.
that
I said
his
my
car
car
wasn't
won't
working.
start.
Oh yeah, I said something about that. You didn't hear me respond to your car not starting? Well, there you go.
Did you make fun of my car?
I didn't make fun of your car.
And you were just like, oh, your car's not starting. That's why you're here. Something along those lines.
Yeah, something like that.
My car's making me weird right now. I have to keep his old battery. Like my dad replaced his battery in his old Chevy, so I just keep his old battery in my car with jumper cables so I can just jump it when I need to. 'Cause you
So,
never know when it's
do you
just
need a new battery, sounds like?
Yeah, but I don't have that money.
That's not even very much money. Don't you have a job?
I do, but I have other things to be saving for right now.
I see. So you're just going to deal with the hassle
So
of
I'm gonna wait until it's
jumping the
old
old
again.
battery.
I'm gonna wait until it's old again. I've gotten really good at jumping my car.
Batteries aren't that expensive.
$100.
Yeah, thereabouts.
I'm gonna wait till it's all the way dead first before I have to spend $100 on it.
That seems like a weird choice, but whatever.
Install it yourself or have them install it?
I'll do it myself.
Well, I'll tell you right now, from personal experience, if you go to O'Reilly's, make sure, double check that they give you the right friggin' battery, because if they give you the wrong battery and they cause you to blow a fuse because you hooked it up correctly, but it's the wrong battery, so the terminals are backwards, they will just do nothing about it except change out the battery while you stand out there for 3 hours fixing the stupid fuse. That's why I don't shop at O'Reilly's anymore. Jerkwads. Okay, number 2. -5, 4. 4, -4, 3. 6, 4, -9, 1. 8, 1, -1, 1. Number 10, 13 free throws, 15 2-point, and 9 3-point field goals. Number 12, -3, 3 1/3. Number 14, 2 0. 16 is 4 0 8. 18 is -1, -3, 7. What questions do we have?
4.
4.
Six.
I got both the batteries wrong, both of the 2x2s wrong.
That's silly.
Everything except number 2. So, yeah.
Number 4.
See you tomorrow.
I love you for your book choice. Yeah. You don't know why it's funny, but it's really funny.
What? For her book choice?
The book Randy's written.
What book did you do?
Oh,
I do think I know why it's funny.
okay. Well, there you go. Okay, we're supposed to solve this using Cramer's rule. So what should we do? No, just kidding. LOL, JK. We're supposed to use inverses to solve this equation. So how do we solve this equation? Great. Augmented matrix. Now what? Actually, that's not right. We're not supposed to augmented matrix. Matrix equation, because we're using inverses, right? And then, yeah, we should find the determinant. Your answer was still correct. 8 minus 3 equals 5. Yes. Now what?
8 minus 3?
Yes. To find the determinant, you multiply the down diagonal, and then you subtract the up diagonal. So -4 times -2 is 8, minus 3 times 1 is 3. Correct. And it's 5. Because elementary, my dear Watson.
Do we multiply the 5 back into the thing?
No.
Don't we turn it into the fraction?
Yes. So 1/5 times -2, -1, -3, -4, right? Where you flip the down diagonal and flip the signs of the up diagonal.
Did all this. I did it, so I don't know. I'm sure where I messed up.
We might be about to find out. Who knows? So -2/5, -1/5, -3/5, -4/5. And then what are we supposed to do?
Multiply it by the other
Yeah.
answer.
Which order?
Row by column.
No, that's not what I mean. Like this times this or this times this. Which side does this one go on? Because heat matters. Yes, it does.
Oh, I did do it.
And then yes, row by column. So, what's -2/5 times 19? -38/5.
Yes.
-38/5.
And then do we add?
That's what I was about to ask. Do we add or do we subtract? We do add. You are correct. And
I don't know what I got wrong.
we're still liable to find out. So plus 18/5. Oh, I can write.
So it's -2/5. Never mind, I know what I did wrong.
Negative. Do you not ka-chink, ka-chink? Or negative times negative, and you got a negative on accident?
1/5 times 19 again.
Oh, gotcha. Do we still need this one? Does other folks still need to finish this one out, or we have as much as we need on this one?
Yeah, you just finish the distributing right, and then you have x, y equals that, and you're done.
Yeah. You do this row by column.
Double checking my numbers.
Okay.
We do number 6.
We could do number 6.
Okay, but the thing is, I got 56/5 for the top row.
Well,
Oh, I didn't check. Never mind.
yeah. Number 6. Number 6 is handy because you're supposed to solve a 3x3 matrix with inverses. All we have to do by hand is find the determinant. If the determinant isn't 0, then shove it in your calculator. Let's do it anyway.
Can we also, so do we have to find the determinant, or can we also just like raise that to the negative?
To get all of the points, you would have to do at least the determinant by hand because, and then that would determine whether it has an inverse. And if it does, you find the inverse on the calculator.
Okay.
Okay, so how do we define the determinant of the 3x3 matrix?
We do the 3 on the outside and the 3, -9, 4, and 20.
I understand what you mean, but yes. So we do 3 times the determinant of 3, -9, 4, 20 minus -2 times the determinant of 6, -9, 4, and is that a 4 or a 9? Now I've confused myself. Yeah, it's a 4. I was right. plus 8 times the determinant of 6, 3, 4, 4.
See, I know what numbers you're supposed to do. Where good pick up. It's the
Diagonals, right?
Not really diagonals. You may be meaning the right thing. Oh, for this, we're still, Hayes talking about going from here to here, right?
Yeah.
Right. Yes, it is the diagonals on where, yeah. First row are the scalars, and it's plus, minus, plus. That's why this minus is here, right? And the 2 by 2s, if we're using this one, then we cross out those rows and those columns, and we're left with this.
oh, it's crossing.
If we're doing these, we're crossing out that row, that column, we're left with this matrix, etc. 60 minus negative, I think I'm going to write that out, 60 plus 36 plus 2 times 24 plus 36 plus 8 times 24 minus 12. I think that one's easy enough, yeah?
On the middle one, that 4, the bottom right 4 should be a 20.
It should be. Which means this is 240.
No, 120.
Yeah, that's true. So 3 times 96 plus 2 times 156 plus 72. No,
8 times 12.
96.
I don't tell.
Why not? As I forgot, see earlier comments.
See,
Well, 3 times 96.
288.
And 2 times 156.
312.
I got 696.
When you did this part.
I did the whole top.
Boy.
Oh, I understand now.
It has a determinant. Therefore, it has a solution. Or it has, that matrix has an inverse. It still doesn't tell us it has a solution. So we're still supposed to solve this using inverses. So now we need to find the inverse of this matrix. So shove it in your calculator and find the inverse.
Just haven't figured out how to do it yet.
Okay.
Well, you got to figure out how to put the matrix in and then just raise it to the -1.
429.
You did it once, and I could never figured out how you did it.
Well, you don't have it, so I can't figure it out again. It's probably in like the home screen. I don't know.
I need to get one of these things. So much easier to
It's
use.
a really good investment.
You could get one of those. I prefer the Casio these days, but those are nice too.
I got this at the Lure like
Anything but
5
mine.
years ago.
I could like go the whole novel in time. Loads of graph.
Well, that one costs less than your battery would cost. Whereas that one costs probably at least as much, if not more. And that one is arguably easier to use in a lot of circumstances.
Gotcha.
The thing is, this is actually allowed to be used on like SAT tests,
That's true.
which is bad.
That's
for your
been true actually for a while, but yes.
What's bad for
Can't have, you can't have one with a computer algebra system though. No CAS models, which makes sense.
Okay, do you need all the magic numbers?
It's the inverse.
Do you want the answer or?
7 over 174, 25 over 232, 1 over 58, negative 5 over 174, and 7 over 232.
And I think I have made a decision that if you want to do, as long as you write what's on the board, if you want to multiply these two matrices on your device, you may do so. Because y'all know how to do that. You're just liable to make a small mistake and miss it, and that's going to be stupid for all of us.
That is
So.
extremely generous of you.
Okay, so then the answer is 138, 192, 104.
Clearly mistakes have been made because no, that is not the answers. The answers are 4, -9, 1.
Okay, whenever I did it initially, I got some numbers correct, so let me look. I just typed in the second matrix wrong, that might be it. Nope, 38, negative 12, 0. Alright.
How much
Is it B
does-
times A or A times B?
It would be this one times this one.
I had that one times that one.
So the inverse of A times B. So this,
No, I didn't write inverse in the next matrix, that was the issue.
did you get it?
Yeah, I already got it. But yeah, I just took the inverse and then you just.
Yep, nope, there we go, I got the answer.
Where'd you get one of those? Ah,
We've had this for ages.
If you want to get one like that,
I don't. That seems way too complicated.
which if you want to get one, basically if you want one that has like touch screen interface and whatever, I would recommend the HP Prime over that one. Because it works more like those, but easier in some places. And it's now you know what my number one, there's several reasons why I like Casio better these days. But you want to know what the number one reason is?
What?
It's because Casio calculator still does this. So I don't have to worry about charging the stupid calculator.
I have to charge the thing once in Blue Moon.
What?
Yeah, same.
I turn on like once.
That's not a rechargeable port. That's to connect it to the computer.
Why is there a headphone jack?
Why is there a headphone jack? There's not a headphone jack. That's probably for other kind of interfaces. But I don't think that's a headphone jack. It would be weird if it had a headphone jack.
The music on your calculator.
People have weird things.
I have
Yeah.
a question about how you want our answers. Because I think I have mine as an improper fraction. So do you want improper fractions?
On this problem or
In general, like on 12. Do you want mixed improper fractions?
It doesn't
or
matter.
mixed numbers?
that doesn't matter. As long as you don't do a rounded decimal when it's supposed to be an exact number. Like I don't care.
'Cause I got 4 or 10 thirds, not
Yeah.
4 and 1/3.
3 1/3, but yes.
So that's fine.
Yes, that is totally fine. What other questions do we have?
Can you do number 10 since it's a word problem?
Did you try it?
No.
Did anyone try it? Then no, we're not going to do it. I'm not going to just give you answers. That's silly. If you have not mentally engaged with the material, then that doesn't seem reasonable.
I read it to see if I understood.
Did you try it? Did you write down any equations? Why not?
Say,
Get problems wrong. Use the brain to engage with the materials.
I just didn't have the time.
Well, that's because you didn't choose the right time to work on it.
Can we do something from 12 to 18?
We probably could. Cramer's rule problems. Which Cramer's rule problem do we have a question on?
let's do Is that the one that turned out weird? 16?
Oh, I just did it wrong.
What?
I just did it wrong.
You just didn't what?
I did it wrong.
Did it wrong.
16.
16. Sure, why not? This is where we ended class last time, basically. Could be a good place to end a chunk this time, and then we can hit the next chunk. Talk about partial fractions. We are expected to solve this with Cramer's rule. So, what should we do? Yes, we should find all the determinants. What?
I know the first one's easy.
Nice. Here we go.
Is there a way to do
No.
the determinant and the calculator that is legal?
I've answered that question to you specifically at least twice. And the answer is still the same.
Okay, so we need to find the determinant of the whole chunk.
Is that 28?
Yes, we do.
This is 16.
No, on the
Yeah.
bottom right. Is that
Yeah, that's 28.
Oh, I forgot to put the D thing.
Four. Then look at all those ones. Isn't that cute?
Wait, why did you put negative 1 times 6?
Signs always go plus, minus, plus. This is this one.
Plus
It's
one.
it's plus, and it's so like if it's minus a negative, it would still be plus in the middle, but yeah. So negative 4 plus 4 is 0. Minus 12 minus negative 3 is 12 plus 3, which is 15. And then plus 6 times 4 is 24 minus negative 6, which is 30. So we've got negative 15 plus 30, so 15. We are in agreement. How you feel about that? And then this method does take up less space on the page than the other method.
Oh, the stupid one type.
Equals.
Wait, why is that 3 positive
Which one?
in the second chunk?
Because it's minus negative 3. This is the completely written out version, yeah? And then
What I
No, you subtract them. When you're multiplying matrices, when you add. When you find the determinants, you subtract.
Well, then how does the first one work?
First one would be -4 minus -4, which is 0. I don't know what I'm writing, because that's not the correct symbol. Plus 1 times 16, -2, 28, and 4. So that's still 0. Handy mandy. Minus 32 plus 28 plus 64 plus 28 times 2 is 40 plus 16, 56. Does that sound right to y'all? So negative, oh yeah, I thought this number was going to get out of control, but it is not going to get out of control. That's false. 60 plus 120.
Yes.
So 60. Seems reasonable. And then the y version, determinant of these guy, 1, 6, 3, and then 12, 16, 28, and then 1, -1, 2. So we have 1 times this matrix minus 12 times the determinant of this matrix plus 1 times the determinant of this matrix. All right. So 32 plus 28 minus 12 times 12 plus 3 plus 6 times 28 is 120 plus 48, so 168. Does that sound accurate? 168 minus 48. It is. So now we've got 60 minus 12 times 15 plus 120. 12 times 15 is,
180.
yep, I was probably going to get there eventually. Is it weight what? Okay. So,
Oh, we got a 0.
why? Oh yeah, it is 0. Yeah. Yeah. Because it's 0. That's why. Easy answer. Okay.
That determinants weren't allowed to be zeros.
That one can't be 0. Because it's these divided by that one. So yeah, that one can't be 0. You were hopeful. You were like, oh yay! It's not that bad.
Just so many repeated writing
I did not say that.
You didn't say that?
No.
I swear you said that.
I don't think I said that. Maybe I did say that. I don't know. There is video evidence of whether I said that or not.
Evidence, submit to the court.
So if y'all want to go and roll the tape and see if I said that, then you can hold me to it. But that's the only way to guarantee that there wouldn't be that. 1 times -2, 16, 4, 28, minus 1 times 6, 16, 3, 28, plus 12 times 6, -2, 3, 4. So, negative, whatever that is. I just did that in my head just a second ago. 40 plus 16 is 56. Minus 64. Minus 6 times 28, 100 plus 28 is 100. We just did that. It's over there somewhere.
120. Oh, just kidding. No.
168 minus 48, which that will be 120 times 24 plus 6. So negative 120 minus 120 plus 12 times 30, which would be 360. So 120, right? Is that what we get as our final answer?
Yes.
Okay. So our answer then is 60 over 15, 0 over 15, 120 over 15. Please don't just leave your answer like that, kids. You're in pre-calculus. What's the last thing that we got to do?
Simplify it.
Yeah.
That'd be 4, 0, and 8.
Do we write it in the parentheses or do we write it in a matrix?
You could do it either way, but if you wrote it as a matrix, you'd have to do X, Y, Z matrix equals 4, 0, 8 matrix. This is probably the easiest way to just write your answer, just as a ordered triple. Let's learn the next lesson, or at least a part of it. I'm sorry. This lesson heads heavily towards a topic in Calculus 2.
We've not even done calculus 1.
That's true. Well, this is just getting you ready for it.
Anybody have a spare piece of notebook paper?
Yes. Do you want graph or regular?
He did say notebook paper, but
Yeah, but he could be fancy.
well, yeah, but that's graph paper. Notebook paper is like lined paper. Warning, the stream's current bit rate is lower than the recommended. Oh well. Okay. So, 6-4, partial fractions.
It sounds so simple and that's how you know it's terrifying.
Well, the first problem type is quite simple.
What page is this on?
398.
We're going to teach the first concept with the example. We are going to find the partial fraction decomposition of two x plus 5 over x squared minus x minus 2. We have graphed some rational things. So what this is asking for is it's asking you to uncombine the fractions. So pretty much every time we've done something like this before, we started with a couple of fractions, we shoved them together and ended up with this. We're going the other way around. So when you look at this problem, what do you think you might do?
Keep the same denominator, do 2x over the denominator and then 5.
So yeah, kind of.
I just want to decompose along with it.
I think there's something that should be like jumping into your head right now.
There's a squared right there, so.
Yeah. What might we want to do with the denominator? I think we should probably factor it, right? That seems like a reasonable thing.
Probably.
Great. That seems helpful. I can't talk right now. I'm doing math teacher stuff. Now, we can decompose this. Well, yeah. We can write a little bit of an equation. Making sense so far? Not too scary yet, except it kind of is a little bit scary.
And that's just like an equation that we're always going to use, right?
Yeah.
So it's the A, the 2x, and the B, the 5.
It's going to be something else. So it's going to be whatever would be here in order to turn this into this. Because to get this same common denominator, you have to multiply this times this and this times this and all the things. But I have to take a pause and use the restroom because, you know, I do. That happens. Y'all can talk to the camera or not. Or you could plug it in, you can stick it in the box and they won't be able to hear you. I'll be right back.
So how's everyone's day? It's been good. How about you?
Really only just woken up, so it's kind of nice, yeah.
Laura's stupid cat woke me up at 6 a.m. this morning. And I usually get up at 6 a.m. But today I was like, I'm gonna sleep in. I'm gonna sleep in, Garrett. Nope. The cat woke me up.
Dana and Randall were both.
Yeah, they're all gone. So it's just me. And I know I'm extroverted. It's only when I stay in the house alone that I realize how extroverted I actually am.
How what?
Extroverted.
Yeah.
It's terrible.
I'm house sitting in a couple weeks for like 10-ish days.
Oh.
And I house sat for the same person a couple months ago. And I was like, coming home from work, I'm like, I want to talk to somebody.
Yeah.
Just the cat and the dog.
And they're also like, Laura spoils their pet so bad, so they have to have constant attention. And I'm like, I don't have time. I need to go and do ballet and go to school. And then they're like trying to get attention. Like, you don't need to be fed. I already fed you.
But they're poofy cats.
This cat, how old
She's 18 in human years.
It's crazy.
She's older than I am.
She used to live with the Bonds, right? Is that the same cat?
Yeah, and Mitzi. So I guess, how old would she be in, or she's 18 in cat years. How old would she be in human years?
I don't know. I know she's scratched Ethan's
At least
face,
100
but I
years.
don't know about anything else.
She's so rude. Grumpy old,
She is grumpy.
grumpy old granny.
So this was like years and years ago. Ethan was like 3, and he was just like on the floor, and then she walked up and like,
Mitzi in her prime.
still grumpy.
She's always grumpy.
Your daughter is so sweet. I love her.
Sweet dog. Spoiled rotten. And a pain in the butt to deal with.
She trained?
No.
No.
No. Lark. Dogs take a lot of discipline to train, as you know. Especially those dogs. Lara does not have any sort of heart to discipline animals. At all.
Okey smoky dokey. We gotta figure out what A and B are. Does that sound accurate? Yes, it does.
Yes, it does.
Just blew out whoever's eardrums. Nobody's currently live, but you know, if y'all choose to use it to study later.
I always do, so
Well, there you go.
I don't remember this.
Good.
Take your earbuds out, please. I love it.
Yeah.
So, what might be a good guess as to what we might do?
Can we factor the top one? Not factor it, but like.
I think we should kill the fractions.
Good idea.
What do y'all think? Y'all think that sounds like a good idea? Like, sure, why not? You're supposed to be telling us what to do. We've never done this before. I think getting rid of the fractions sounds like a great idea. Let's do that.
Shall we get rid of that?
So, what's going to happen on the left side of the equation?
It's just gonna be 2x plus 5.
Yeah, denominator is just going to go done.
Do you multiply the top times that?
Yeah, but we're not going to distribute it. We're going to leave it just. Yeah, so, yeah, you multiply the whole fraction, right? So on this one, the x plus 1 cancels. So we end up with a times x minus 2.
What? No.
That'd be
Oh, I did it all the way around. Just kidding. How about plus 1? I don't know I don't know where it went wrong, but yeah. And this would be b times x minus 2. Great. Making sense so far? Pretty easy peasy so far?
so hard, Sean.
No big deal. What might we do next?
Are we trying to solve for A and B? Well, no doubt.
Yeah, what's our goal here?
We need to know what A and B are.
So we are solving.
We are solving for A and B, which means we're going to ultimately need 2 equations. Oh no.
So we're gonna have to split the equation somewhere.
What might be a next step?
Consolidate. I don't know how you do that.
Do you want to get A and B by itself?
Unfortunately, we do. We do want to do that, which means we're going to have to do what?
Kill one of them.
Divide.
Should we divide by itself?
Or we just undid dividing.
We did just undo dividing.
Is it if we have fraction equals A plus B?
In order to get A and B by themselves, which was your suggestion, and it was a good suggestion, we're going to have to distribute. So we can we can decouple things.
A times X.
What could we do now?
Can we take out something? I know we can't do this.
So I don't know for sure what you mean, but kind of we're heading towards trying to take out something to make something work.
Um,
If we factor out like they're not on the whole thing.
So factoring is a goal we have. Let's do this.
If we like factored out the A,
It turned back to this. Yeah, so not the A. So not that, right? You thought down all that path and exit out yourself. Good job. But what if we did this?
I bet he's dividing it all by 0.
I did rearrange it.
And how is that gonna help us? It does look better.
oh, can you factor by grouping?
Kinda, yeah. We are gonna just partially factor something. What are we gonna do? What are you thinking?
You can take out an A.
We can. We can turn this into, and I'm writing this way. We usually write the factored thing out in front, but I'm writing it this way, and I'm doing that for a reason. And I'm even to make the next thing even more clear. I'm going to put parentheses over there.
So you factored out an X?
On the first, just out of the first two, right?
Ah, okay. I
Okay.
didn't know you could just factor out of that. I thought
You did, you just forgot. It wouldn't be, so like you can't if you're trying to like set each factor equal to 0 or something like that, right? Like these would have to match and you have to pull that out and do all this grouping stuff, but that's not really quite our goal. So, do you see something right now?
We have an X by itself.
We have an X by itself-ish. The left side and the right side kind of match with extra junk involved.
Yeah.
What do I mean?
It means it's something X equals something.
they're addition problems.
We can now do this. Are you ready?
No, but okay.
Oops.
Okay, explain.
You explain. Okay,
We have, okay, it's 2 times x, and we have a plus b times x, and then plus
Yeah.
something, which that's
Yeah. So this is something times x, and this is something times x, and this is plus something else. So all of this, in order, if these sides are going to have to match, then this has to equal this, and this has to equal this. Right?
Yeah, I got it.
okay.
So you're kind of ignoring the X's?
No,
I'm not ignoring them. They just have to, because they have to be the same on both sides. But because they're both the same on both sides, I can pull out those 2 equations from this one equation with all this mess.
Okay, so then are we going to have to just...
Solve the system. Surprise, surprise. It's like the whole point of this unit, right? So you probably could have guessed that we're going to end up with a system eventually, right? It's been a system the whole time. So you can solve it however the heck you want to solve it.
Besides punching it in the calculator.
You can punch it in a calculator if you want, but you can probably do it by hand faster.
Why did you ka-ching?
I multiplied everything on the second one times -1.
Okay, and then how did you get to 3b?
I eliminated.
Oh, we go
I used elimination. I multiplied this times -1, and then these cancel. 1b plus 2b equals 3b, 2 plus -5 is -3, and divide by 3, and we end up b equals -1. Substitute back in. And a equals 3.
Elimination.
So now we have our answer. We just need to write it as our answer.
Oh, wait, just kidding. Wait.
No.
No, sorry.
Yeah, what?
I never do. No, I'm just kidding. So our answer is 3 over x minus 2 minus 1 over x plus 1.
What is that? What's that?
That's from like the A ratings.
So,
We should look
yeah,
at
I
that.
know.
Alright, so that's.
Okay, I'm still confused how that happened.
The elimination thing?
Which,
How you went from the long equation to
let me put some colors on the board. I think that'll help.
And also, like, Cramer.
from your big solution.
My calendar's yelling at me.
Your calendar is yelling at you.
I make
This AI is getting out of control, bro.
I
Okay, so
know.
this, it's a pattern. This side, and maybe if I write it in like more generic things, if we have y times x, and then over here we have equals z times x, and then we have the same sort of pattern looking thing. And this one of plus a times plus a, we'll just use that, and then plus b. So see, the pattern matches. So we've got something times x plus something else, something times x plus something else, which means that what's in front of x here has to be the same. So in this case, y would equal z, and a would equal b, because they're in the same place on the equation. So like, if we have 5x minus 2 equals 3x plus 4, that's a crappy example to get you there. Does that help what I did in the other bit?
The x's will go together and then the non-x's.
Yes, yes. Okay, how we doing? All right, I should assign a little bit of homework, and then we'll do a few more, and then we'll have a test later.
We'll have a test later.
Potentially. We get to do division on the next example. I haven't done polynomial division in a while. Yeah.
This is still better than the last one.
Okay, your homework is page 402. Wow.
What, page 402?
Page 402, numbers 1 through 6 all. Whoa. All of them. All 6 of them. You've got to go write some as you read.
It's one of our homeworks.
As you read. Ah,
I texted the
that
teacher.
makes more sense.
Because we didn't have any internet, I texted the teacher. I was like, hey, I don't have the as you read questions. Can you send them? And she was like, yeah. You sent me the wrong ones.